For today's video, we're going to look at some solutions from your assignment on Monday. And what I'm going to focus on is the problems I think you would have struggled with, the ones that I find a little more challenging. However, I'm going to start with number 8, which I don't think is too difficult, but there's a step at the end I think many of us would have forgotten to do. And I want to go and review that step before we look at some of the more challenging problems. So in number 8, you're going to notice that you have the same base in the numerator and the denominator. They're both z's. And we also are dividing. Whenever I see a fraction, that means division. So hopefully you reminded yourself what to do when you're dividing with the same base. You're going to take those exponents, we're going to use the quotient rule, and we're going to take those exponents and we're going to subtract. So I'm going to take -4 and subtract 12. And remember, if you can't do that in your head, just use a calculator, no big deal. And -4 take away 12 would give me -16. So many of you would box your answer here, but since the direction said to simplify, we don't like to keep a negative exponent in our final answer. We need to simplify that. So what we're going to use now is our negative exponent property. What the negative exponent property tells you is that you can just take your fraction and flip it, and it will change the sign of your exponent. So all we have to do is remember that there's an imaginary 1 underneath. So now I have a fraction. And all I need to do now is flip it or take the reciprocal. And when I flip it or when I take that reciprocal, the exponent will change signs. So when I flip it, the 1 will go from the bottom to the top. And the z to the -16 will flip to the bottom, but now it'll be +16. And now this would be a simplified final answer, and this is the answer you would want to box. The next one we'll look at is number 10. The reason I want to look at number 10, it uses two different properties, and it uses the same property as number 8, but it also uses a new property. And what I notice is on the top, I have parentheses with two exponents attached. So I have a base 4 with a raised to the second power, and then it's raised to the 6th power. Whenever you have two exponents attached to the base, you're going to be using the power rule. And what the power rule says, it says to multiply your exponents. So I'm going to do 2 times 6, and that's going to be 4 to the 12th power. The 4 to the -3, I just brought down at the bottom still, so it still remains there. And now you're going to notice that this looks just like number 8, and we're going to use the quotient rule again. We have the base 4, we're dividing. Once again, we're going to subtract our exponents. And 12 take away a -3. Be careful there. 12 take away a -3 will be the same thing as 12 plus 3, which gives us 15. So our final answer will be 4 to the 15th power. Next one we'll look at is number 11, and this one actually has two different ways you can solve it. So I'll go ahead and go over both ways. The first way you can do this problem is by using the power rule first. So I notice that I have parentheses around the whole thing. So this 3, this exponent, is being attached to everything. It's being attached to the numerator, and it's being attached to the denominator. So I have to make sure I distribute it to both pieces. So when I take the 3 and I multiply it to the top, I'm going to use the power rule once again. This 2 exponents we say to multiply. 3 times 5 will give me 15. And when I do 3 times the bottom one, that'll be 3 times 3. That'll give me 9. So you're going to have 2 to the 15th over 2 to the 9th after you use the power rule. And now once again, we have the same base and we're dividing. This reminds you to use the quotient rule. The quotient rule says to subtract. And 15 take away 9 is simply 6. So your final answer is 2 to the 6th power. So we can do number 11 a different way. Now we can just flip it. We can do it the other way. In other words, instead of starting with the power rule, this time I can start with the quotient rule. So I'm going to do 2 to the 5th power divided by 2 to the 3rd power. I'm going to subtract my exponents. 5 take away 3 will give me 2 to the 2nd power. And I still have it all raised to the 3rd. And since I have two exponents again with one base, that tells me to use the power rule. The power rule tells me to multiply. 2 times 3 gives me 6. And as you can see, we got the same exact answer, but we did steps in a different fashion. Whatever one you feel more comfortable with is the one I want you to do. Personally, I always do the second way here. I think it's a little easier for me. Next problem I want to look at is number 13. We have k to the 36 times k to the 4th on the top side. So what I notice is I have the same base, and this time I'm multiplying. So we're going to use a different property here. When you have the same base and you're multiplying, we use what we call the product rule, and the product rule tells you to add your exponents. So 36 plus 4 will give me k to the 40th. That k to the -2 I just brought down. It's still there. And then once again, you should know what to do now because we've done this 3 times now. When I have the same base and I'm dividing, we use the quotient rule, and the quotient rule tells you to subtract. 40 take away a -2. That's the same thing as 40 plus 2. So you're going to get k to the 42nd power as our final answer. And then the last one I think you would struggle with is number 16. It's a little crazy looking, but it's not too crazy, or not too crazy difficult is what I should say. What I have is I have a bunch of different bases. I have a 2, an A, and a B on the top, and then on the bottom I have a C and a D. So we have 5 different bases going on in this problem, and they're all being raised. If you see the parentheses, so everything is being raised to the 3rd power. So that means we're going to have to use the power rule, and we're going to have to apply this 3 to every single base. So I'll begin with the 2. 2 to the 4th to the 3rd power, that means 3 times 4. That's going to be 3 times 4 gives me 12. So I'm going to have 2 to the 12th. The A, there's an imaginary 1 there. So don't forget that. So it's going to be 3 times 1. That's going to be a to the 3rd. The B is going to be a -2 times a 3. That's going to be a -6. And then for the bottom, we're going to do the same thing. For the C, we're going to do 3 times 3. That's going to be 9. And for the D, we're going to do 5 times 3, and we get 15. So this is the answer you should get after you distribute that 3 onto every single base. And then I look at this problem. I look at, are there any bases that are the same? And as I look, I have a 2, an A, a B, a C, and a D. So none of them are the same. So all I can do now is make sure that it's in simplest form. And I notice that my B has a negative exponent. So I need to take care of that negative exponent. I need to use a negative exponent property. And what that says is take the B from the top and throw it to the bottom so it becomes positive. And then it would look something like this. So instead of the B being at the top, it's now at the bottom. And then I just wrote it in front of the C to be in alphabetical order, just so it looks nice and neat. And this is the best answer you can come up with for number 16. Okay. So I hope that helps. We're just going to be doing review for our online lessons and intervention, nothing new. What I'm going to shoot for is just doing 3 lessons a week. I don't want to overwhelm you. I don't want to do problems every single day. So I'm going to post an assignment on Monday, then post a video on Tuesday that you can look at and check your answers with. And then on Wednesday, I'll post a second assignment. Thursday, I'll post another video where you can check your answers. And then on Friday, I'll post a 3rd assignment, and then we'll just repeat that. Monday, I'll post a video and an assignment, and then we'll just repeat that cycle till the end of the school year.